Okay, welcome. This is Dr. Morton, and I'm want to show in this video give you some help with your group projects. And I think you'll find if you after you see this video, you'll feel a little bit more relaxed and comfortable that this is going to be doable. Now, at this point, we haven't quite covered all of the information that you're going to have to do the project. We haven't done K-maps yet. We haven't explained how to do shared terms and some other things. But as you work along, we'll cover all that, and hopefully it'll all make sense. We haven't explained how to convert it from an AND/OR network to a NAND/NAND, or from an OR/AND network to a NOR/NOR. But we'll get to that, and it'll be fairly straightforward. All right. So with that, there's an Appendix A that I'll put on the blackboard. Eventually, it'll be at the end in the book, but right now, the one in the book's a little goofed up. And so, let me just open up this document. If you read through this, this basically shows you sort of how we want the project to go. And then down here, you'll see that we have basically a list of the various PowerPoint slides I want you to come up with, and then you'll also have to do a simulation. What the project involves is using this 17 segment display, but we're going to skip the decimal point here. We're only going to use the 16 segments, and we've done it in more pictorial form. Well, right here, say for an A. You can see we have segments 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. Now you can number these differently, and you will find different numbering out there, but this is a pretty good way to do it, and so this is how we're going to do it. So in the case of the A, so let's say you're assigned to do A, B, C, D, E. Okay, great. So your first one is A. So you draw that in here, and you use the same segments here. So this would be obviously segments 1, 2, 3, 4, not 5 and 6, yes, 6, 7, and 8, yes, 9 and 10, and then not 11, 12, 13, 14, 15, or 16, just like here. Okay? You do the same for B, and C, and D, and E, and then finally, you would put those all into your truth table. Each one of these digits would represent a row. You would have 3 independent variables. We looked at that up here. Basically, A, B, C. And when A, B, C are all 0, you would display your first character. And when it's A, B, C are 0, 0, 1, you display your second character. And when they're 0, 1, 0, your third. And when they're 0, 1, 1, your fourth. And finally, when they're 1, 0, 0, your fifth. And then for 5, 6, and 7, they're don't cares. And so that'll help you simplify and get the simpler solutions, but it's okay. You don't... there's nothing for those last 3 rows. They're just don't cares. Okay, so let's look at the assignments. So your assignments are at the end here. I gave you some steps to go through too. This will help you kind of think your way through how to approach the project. And you can also divide the work up among the team. But some things you should probably duplicate, like the truth table. Double check it. Make sure you've got it exactly right. All right. So group 1 will do project 1, and that means you'll display the lowercase letters A, B, C, D, and E. Again, using 3 inputs, and the characters. When you have the 3 inputs at 0, you do an A. When they're at 1, you do B, 2, C, 3, D, and 4, E. So that would be 5 different things, 0, 1 through 4. And then there'll be 3 don't cares at the end. For this project, they're required to do NOR/NOR. So I'll just let you know that in order to do NOR/NOR, you have to come up with a POS network. And then you can easily convert that. If you come up with a SOP network, you can't convert it to NOR/NOR. You have to then go back and do it in POS form first. Group 2 is going to have the same characters, but they have to implement their simulation with a NAND/NAND network. So their K-map, their truth table would be very similar, but all their K-maps and everything are going to have different solutions because they're going to use the max terms, the zeros, to come up with their solutions. because they need, sorry, this group needs it in POS form. This group needs to use the ones and have the minterms. And then that's the same way all the way through here. There's a couple where we have 1, 2, 3, the @ sign and the asterisk. So up here you have to figure out the @ sign and the asterisk, and they're really listed. These numbers here, 2, 0, and up here, those are the the hex codes in ASCII for these characters. So for instance, the @ sign in ASCII is 40 hex, and so that's and here's the asterisk. And then here's the $sign, here's the percent sign, that's the ampersand. But if you don't know which it is, you can check the ASCII code and see. Remember to use these representations, and we won't use the decimal point. The only place where it shows up is in the exclamation point here, which is 21 hex, the period, which is 2E hex, and the question mark, which is 3F. So you skip those, and I didn't put those in any of the assignments. Okay, so let's look at let's change this out, and hang on one second. Let's look at the a group's presentation. Okay, so here are their slides. I've blacked out their names. So their assignment was K, L, M, N, and 0. So, and here are the segments they needed, and they also were required to do it in NaN. So they have to come up with the SOP solution in SOP form, and then they can convert it from SOP to NaN. You can't convert from POS to NaN, and you can't convert from SOP to NOR. So you have to get the right form to start with. Okay, of course you can convert from SOP to POS, but that's a bit of a hassle. It's better just to work the POS solution from the get-go. All right, here's their truth table. Sorry. Notice they have 3 independent variables, ABC, 8 rows. The last 3 are all don't cares. The first row is the A character. The next row is the B character. The next row is the C, the D, and the E. And you can see that many of the outputs, and they label them 0 through 16, which 16 would be the decimal point. Forget that. You probably should label them F1 through F16. And that'll make more sense because that corresponds with the segments, which are labeled 1 through 16. So anyway, so this is their first two, segment 1 and segment 2, were both exactly the same. They were either off or they were on for any particular character, both of them. And then 2 and 3, the bars down the side, they were either on or off, both of these. So what's nice is you only have to generate one output, and you can just send it to 2 of the segments. In this case, segment 1 and segment 2. In this case, you generate one output, and you can send it to 2 and 3. And look at 4 and 5 were identical too, so you can do that as well. Then these 2 were all 1s, so that we're just going to connect them to the power and turn them on all the time. This one and these 2 and these 2 were all 0s, so we're just going to leave these off. And then we have 1, 2, 3, 4 other functions. And notice, so we really only had to do 1 for these 2, 2 for these 2, 3 for this one, and then 4 here, 5, 6, 7, plus some on and some permanently off. So 7 networks they really had to devise. And when they did those, they could share, they actually identified, here are their K-maps, they actually identified a bunch of shared terms. You can see right here, well, they're their final expressions. Then you can see where they had shared terms here. And so, for instance, if you look at this, here's an A prime, B prime, C prime. So, yeah, well, okay, well, here's an A, and here's an A, okay, and here's an A. So you only have to generate A once. And then here's BC. So you can share the BC output with here. It doesn't have to be generated again. And BC prime, they can share that. So they could really reduce their gates to 1, 2, 3, 4, 5. Actually, they don't have to do any here, just an OR gate. So 1, 2, 3, 4, 5, 6, and you can do you can share the A prime, B prime, C prime. So actually drop that. So 5. Then 6, 7, 8, 9, 10, 11, 12, and don't even need a gate there. So 12, they could have gotten by with 12 gates plus 3 inverters. And actually, if you look at their key map, let me do their simulation, which is here. So here's the simulation, and you can see that they used. I provided this little thing, although there's some better ones out there. So I just kind of made this 7-segment thing up myself. And if you connect these lines, then you turn the segments on or off. So some of these are permanently off, like all the ones connected here, permanently off, and so forth. And then some of these are driven. So you can see they have a lot more. They didn't really reuse any of their outputs, and so they had multiple inverters on some of these. So anyway. They used, of course, the NAND gate, the NAND gates for inverters, and that's fine. That's what I wanted them to do. Okay, so they have 3 buttons here. Notice the button is this little thing up here. There is a button down here, but don't use this button because you use the poke tool up here. It's the little finger thing, and when you poke it, it's on when you poke it, but when you let go, it switches back off. So that's not very useful when you want to have more of them turned on than one at the same time. So use these. And when you use the poke tool on these, it turns them on permanently. So for instance, poke, it's on, poke, it's off. And it stays on and off. All right, so we start with a K, and then 1, we get an AL, KL. And then for 2, we get M, KLM. For 3, we get KLMN. And finally, for 4, we get O. So K, L, M, N, O. So that's all of the ones that they were required to display. And they did a nice job, other than they didn't use a minimum number of gates. They used a lot of gates that they didn't need. All right. So that's that project. So let me switch back here. Okay, so that's pretty much what I wanted to show you. So if you take your group number, and the project number at the end of the appendix shows you which project you're required to do. It also shows you if you're supposed to use a NOR implementation or a NAND. And this previous group used NAND gates. The NOR, if you have the NOR, then you have to use all NOR gates. And for the NOR, you do have to start with a POS form. With NAND, you start with SOP. All right, I think that does it. We'll stop here, and hopefully, if you need help, be sure and let me know. I'll be happy to give you some help. But I'd like you to try and get the truth table done by a week from this Friday.